Sir, why can I suddenly see the light inside the milk?
3 beakers, 3 beakers, 3 secrets. Interesting. The light becomes visible only after entering the milk.
Sir, why can we see these particles in milk but not in salt water?
Before understanding milk, let's understand a solution. A mixture that is the same throughout is called a homogeneous mixture. Sugar keeps dissolving in water. But can it dissolve forever? If more solute can dissolve, the solution is unsaturated. If no more solute dissolves, it is saturated. Heating allows more solute to dissolve. After cooling, the solution may become supersaturated. Let's classify these 3 mixtures. We have suspension, colloid and solution. Particle size and behavior define them. All mixtures are not the same. The salt didn't disappear, it spread evenly throughout the water. It spread evenly throughout the water.
Sir, if the salt is still there, why can't we see it?
A solution forms when one substance dissolves completely in another.
Sir, these 2 mixtures don't look the same. Don't look the same anymore.
These particles are large enough to settle down with time. This type of mixture is called a suspension.
So these particles can actually be separated from the water?
Not all particles are the same size. Some are much smaller than suspension particles. The particles in milk are small, but they scatter light. This is the Tyndall effect. Milk is a colloid, where tiny particles stay dispersed without settling quickly. Colloidal particles are small enough to stay dispersed, but large enough to scatter light. Colloids remain stable and their particles scatter light without settling quickly. Colloids are not just in the lab, they are part of our everyday life. A colloid has 2 parts, tiny dispersed particles and the medium in which they are spread. We classify colloids based on the state of their dispersed phase and dispersion medium. For example, liquid in gas forms fog. In milk, tiny liquid droplets are dispersed in another liquid, so it is a liquid in liquid colloid. A mixture that is the same throughout is called a homogeneous mixture. In fog, tiny liquid droplets are dispersed in air, making it a liquid in gas colloid. Paint is a solid in liquid colloid, where tiny solid particles remain dispersed throughout a liquid. As particle size increases, mixtures change from solutions to colloids and then suspensions. Fog and milk look different, but both are colloids that scatter light. Milk, fog and paint may look different, but all are examples of colloids. Suspensions separate on standing, but colloids remain dispersed for a much longer time. Suspensions can be separated by filtration, but colloids usually pass through ordinary filter paper. The secret is particle size. It decides whether a mixture becomes a solution, colloid, or suspension.
Why do all mixtures look so different but can be separated?
Different mixtures require different methods to separate them based on their properties. This is just the beginning of chemistry. Mixtures have three types: suspension, colloid, and solution. They behave differently based on particle size. Mixtures are classified by their particle size. Muddy water is a suspension, milk is a colloid, salt water is a solution. Different mixtures need different separation techniques depending on their nature. We can use filtration for muddy water. Evaporation separates salt from water. Some need advanced methods. Some mixtures need high-speed rotation to separate fine particles. This method is called centrifugation. Centrifugation uses rapid spinning to separate denser particles from a mixture.
What will happen if we heat this salt water?
The water will evaporate and only salt will remain.
So we can separate salt like this?
Yes, this method is called evaporation.
Is this how we get salt in real life?
Yes, seawater is evaporated to produce salt.
So science is used everywhere.
Exactly, that is the power of chemistry. Distillation separates liquids by heating and cooling them.
So this is pure water. Can we really separate liquids like this?
Distillation separates liquids based on the alcohol evaporates first and is collected separately. So different liquids separate like this. Have you ever wondered how a single black ink hides many colors inside it? Today, we'll reveal its hidden colors.
Will black ink really split into colors?
Chromatography separates substances based on how they move through paper with water.
Wow, black ink had so many colors.
As water moves upward through the paper, it carries the ink particles with it. But not all particles move at the same speed. That is why black ink separates into different colors. This technique is called chromatography, and it helps us separate substances that look like one single color.
Now I can see black ink is not really black.
Science reveals what is hidden to our eyes.